Alright, so we look at some mixed area problems. Before I do any teaching about what mixed area is and all the stuff in black on the right hand side, I wanted to get a problem on the board and hopefully help us figure it out for ourselves. So in this situation, I'm basically asking for the area between 0 and 2 of the function x minus 1. So I go through my process, x squared over 2 minus x, 0 and 2, plus c. And then I sub in my values, so I should have 2 squared over 2 minus 2 plus c minus 0 squared over 2 minus 0 plus c. Cancel the c's, everything here is gone because of zeros. So I'm left with, what is 2 squared over 2? 2 minus 2 is? Wow, wonder how that happened. We've got no area, but that function, if I sketch that function, there's going to be an area under the curve, correct? So explain to me why my answer is 0.
It only finds the area above the x-axis.
Kind of. Okay, so this is my little Cartesian plane. The function's going to look something like this, correct?
Is it because it's spinning?
Nah, helps. So I want the area between 2 and 0, correct? And that's what my function looks like. Any ideas why I might have an area of 0? Emma? So the area here is negative a half. The area here is positive a half. What's negative a half plus positive a half? 0. So the reason I did that is because I'm trying to show you that in mixed area problems, when we integrate, the sign of the area does matter. So if we've got negative area, it's going to stay negative. Cool? And we might be asked sometimes in mixed area problems just to do that. And there's nothing wrong with just integrating that and finding out the answer 0. Nothing wrong. But we do need to be able to differentiate between when we're asked to find the total area and when we're asked to find the signed area. Cool? Signed area accounts for sign, so the sign remains with the area. The negative sign remains in my value. Cool? Unsigned is where I remove the area. Before I teach you how to do this, what do you reckon I need to do? I want to find out the total area. So tell me the total. What's the total area for this problem? What is the total area? 1 unit, alright? How do I get there? You can see it, explain to me the process. Neglecting negatives, very good. I can't just write in my maths though, can I? I can't just write neglect negatives. How do I write neglect negatives in maths? Absolute. So do I want the absolute value? Because if I write the absolute of this, is that going to change anything? Still going to have the same problem, correct? So what do I need to do before I, like absolute, absolutely part of the solution? They're absolutely part of the solution, but it's not the only part. What else do I need to find out? There's something I have to do before I start integrating it. What do I want to do with this? How did you know it was 1? What did you do? How did we know the area was 1? What did we do? We added them together. What was the point in which we had to start separating them? Because we've separated these into 2 parts, haven't we? What was the thing that made us know that we had to separate it? What happens at the point when we break this up? Yes, we want to know when y goes from negative to positive. What's the number between negatives and positives? So we want to find out, before we do anything else, we want to find out when y equals 0, correct? So the first thing I want to do is 0 equals x minus 1. What's that called? When we want y to equal 0, we have a funny name for that we learned in grade 10. X-intercept. So we want to find the x-intercept. So once we find our x-intercept, which is, what is our x-intercept? 1. I then identify, look, I know there's an x-intercept at 1. Is 1 in my domain? So what's this problem? It's the area between 0 and 2. So is 1 within my domain? So I want to break this up. How would I break it up? I'd go between 0 and of my function plus the integral between 1 and 2 of my function. What was that thing that someone said before? I'm absolutely certain someone mentioned it. Absolute values. That's the negative part, correct? Does it matter if I put it around both? No, doesn't matter. All it means is whatever value I get, I need to make it positive. So go through and do that for me. Same questions. So what is my signed area in this problem? What is my signed area? 0 units. The way I remember that, signed is the smaller value of the two. It's always smaller or equal to. And secondly, what's that S look a little bit like? Okay, I just use the smaller, that'll be right. Alright. Use the smaller, that's the better way to remember it. Unsigned, we want the total area. Okay, we want the total area, which removes the sign from each component of our area. How do I remove the sign? How do I remove the sign? What technique did I use to remove the sign from my areas? Absolute values. I used the absolute value on my negative and that turned it into a positive, correct? I've removed the sign. At what point do I need to know to break my area up? What am I looking for before I start the problem? X-intercepts. Really easy when we graph it. Do we need to graph it every time though? No, if we can find our x-intercepts, then what do we ask? We find our x-intercepts, and then we ask, is there an x-intercept within my domain? If the answer is yes, we break it up. If the answer is no, carry on. Happy with that? Let's talk about how we do it on our calculators now.